Hi, in this video, we're going to discuss the perimeter and area of four-sided figures. A four-sided figure is called a quadrilateral. That's quad four. Lateral would be sides, four-sided figure. So we're going to discuss now perimeter of any four-sided figure or any figure really is just all you have to do is add up the sides, right? It's the sum of the sides. So perimeter equals the sum of the sides. We're adding those outside sides. If they only give you two sides, like this is 8 and this is 7, then the corresponding sides, especially if it's a rectangle, would also be equal. And then we would just add those up. Maybe these are in terms of feet. So 8 feet, 7 feet, 15. 15 foot plus 8 is 23, and 23 plus 7 is 30. So we could add them up in any order. It doesn't really matter. So the perimeter is the sum of the outside. It's the outside of the figure. And area is the measure of the inside. Measure of inside. And each figure has a unique formula. So we're going to go over those formulas for the area. And then we'll do some problems at the end, kind of putting it all together. So let's take a look at the area. So perimeter is just basically just adding all the sides together, even if it's kind of a weird looking thing. Let me give you one more. Say we had something like this and like this and like this and like this. It's a four-sided figure, but it's kind of strange. This is 4, 3, 5, maybe 6. All we have to do is add that up in any order. 8 and 6 is 14 and 4 is 18. And we would write the perimeter is 18. And whatever the units are, meters maybe. Meters. And you could add up 6 and 5 is 11, plus the 4 is 15, plus the 3 is 18. So it's just a matter of adding up all the sides. Now, let's get into the area. The area is the measure. If we could divide this all up into little squares, 8 squares this way and 7 squares this way, we could count up all those squares. But that's sometimes difficult to do. So instead of doing all that work, what we want to try to do is figure out a formula for it. So let's start out with a rectangle. Rectangle is a four-sided figure, but all the angles are 90 degrees. Each one of these angles is 90. We could put little boxes in them that represent a 90. So you could see if this was 90, 90, 90, 90, they're going to add up to 360 degrees. But we're more concerned with the area inside. So the formula for the area of a rectangle is area equals length times width. So if we know the length, let's take that 8 and 7, 8 feet, 7 feet. If we know the length, we know the width, this would probably be the length, and this would probably be the width. We can just times them together. 8 feet times 7 feet would be 56, and then we got feet. So we write that as feet squared. So area is always in terms of square feet, square inches. You know, back when I went to school, they used to write it as square feet like that. But now this is a more common way of writing it, feet squared like that, square feet. So, okay, so that's the area of a rectangle. Very easy to do. Now, the perimeter, they can give you a formula, P equals 2L plus 2W. You really don't need that. You could use that formula, but you could just fill in these missing dimensions like we did up here and just add them all up. make sure you have all the dimensions. If you only have 2 of them, it's not going to be 15. You have to have all four sides. We had just done that one. We said that that was going to be 30. The perimeter is 30 feet. So, okay, area of a square. Well, area of a square, let's see if I can draw a halfway decent square. This would be the length and the width. The area is still the length times the width, right? But since they're both the same, this side and this side are exactly the same. We could say the area is side times side, or side squared. So if we do one of the sides, would say 6, the other side has to be 6. So the area is the side times the side, 6 times 6, or 6 squared, which is 36. But you could still do the length times the width. It's really the same thing, just a little bit faster to do it. And of course, they could say the perimeter is 4s, 4 times the side, because each one of these 6, 6, 6, 6, there's 4 of them. Or you could just add them all up, 6 plus 6 plus 6 plus 6. So the perimeter is 4 times 6 is 24, a little bit faster, or the perimeter is 6 plus 6 plus 6, plus 6, 24. Okay. So perimeter, you just add up the sides. Area, a little bit, length times width. Okay, what about a parallelogram? Parallelogram is kind of like a rectangle that somebody sat on. Okay, you had a base here and a base here. These bases are parallel to each other. And then you have a side here and a side here, and these sides are parallel to each other. If you were to turn this, they'd be parallel. Okay, so that's why they call it a parallelogram. 2 parallel sides here, the base and the top are parallel, the sides are parallel to each other. But it looks kind of like a rectangle that somebody sat on it. The formula for the parallelogram is area equals base, or the bottom right here, times the height. Okay, so let's say we had this parallelogram and they gave us this side is 6 and this side is 6 and this is 8 and this would be 8. Well, to find this, the perimeter, we would just add all the sides. But to calculate the area, we need the height coming up and down. We don't really want these sides. These sides are going to throw us off. What we need right here is the height. How tall is it? So when you're trying to find the perimeter, don't add all these measures, including the 5 together. You can add the distance outside, but don't mess with the inside. So this would be 5. Area is base, the bottom, times the height, 5. And of course, these might be in feet. They have to be in the same measures. So area is 40 feet square, or 40 square feet, like that. All these area is always going to be in feet squared, square feet. Whether it's a circle, a triangle, it's always the same. So base times height, parallelogram. Ignore the sides, you need the height. They might also draw it this way, 8. And then they might put a little line coming down here on the outside with a little dotted line like that. See, it's perpendicular. Height has to be perpendicular to your base. So this would be 5. Or 6, I guess we use 6. Oh no, it's 5, yeah. So this was 5 feet. We could take this 8 and put it down there. So base is 8, height is straight up and down. It has to be perpendicular. In other words, this is a right angle right here to the base. Right angle. Important. Okay. Another one. Okay. Page 424, you have the formula in your book. And also on page 425. But what we want to look at now is a figure called a trapezoid. Trapezoid usually looks kind of like a lampshade. Okay. It's sort of like a parallelogram. These are parallel, but then usually this side could come straight down or it could be on a slant. Okay. And this is if we want to find the area, the perimeter, we would just add up all the outside sides. But if we want to find the area inside here, then the area inside, we call this base 1 and base 2. We could call it the bottom and the top if you wanted to. And we need a height. We need a height coming up and down. So area is the height times base 1 plus base 2, and then we divide the whole thing by 2. So it's a little bit more complicated formula. We're going to add these two bases together, multiplying by the height, and then divide by 2. 2 is part of the formula. So it's just a matter of putting numbers in. So let's draw one here. And let's say the height. Let's put in a bunch of measurements though. This looks like a 7. This looks like a 10. This is a 12. This is another 7. And this is a 6. And we want to figure out the area. Well, once again, they give you more information than you need. They like to trick you. To find the area, we don't need this 7 or this 7. All we need is the base, the top, and the height. So area is the height, 6, times base 1, 12, plus base 2, 10, or the bottom, top. And then we're going to divide it by 2. So 12 times 10 is 22. You could divide by the 2 right away if you wanted to, but let's just leave it like it is. Then we can multiply that together. I believe that's 132. And divide that by 2. And the area is 64 and 66. 66. And we're called this, let's say this was in inches. So then this would be inches squared. If we wanted the perimeter, we would just add the 7, the 12, and the 10, but not add the 6 because that's inside. So this would be 7 is 14, and 12 is 26 plus 10, I believe is 36. And that would just be inches. 7 inches, 7 inches. So we could add that up, So there's perimeter and area. And they might have it all in one drawing because they want you to find the perimeter, but they also want you to find the area. So we're not going to use the 7s for the area. Now, in your book, they have some problems, and I want to go over these because these are kind of interesting little problems. So let's take a look at these. I had a student a while back, and we were working on these problems, and we were using this formula. And the student told me, and I never thought about it, that this formula right here can work for any four-sided figure. It could even work for, I mean, you wouldn't probably want to use it for a rectangle, but it has a base 1 and a base 2. It has a height, and then we divide it by 2. It's just that the two bases are the same. So we could use this for any, even a parallelogram or anything. This formula would still apply. You could actually use it, but because it is kind of long and difficult, we usually don't use it. So I'm going to try the first problem right here and see if I can do it. Sometimes it helps to draw the picture. This is 15:8. Notice there's a dotted line. That's indicating height. This is 15. And we're assuming that this 26 is the base all the way across here. Probably should have put arrows, but they didn't. Okay. The area of this is going to equal, and sometimes they write this as 1/2 h, but I think, once you see a fraction, students get discouraged. So I like to write it as h b1, and you don't have to use capital B's. I don't know why I did. Over, I could use a capital H if I want. Over 2. Area is the height, which is 12. And what is this in? This is in inches, these two little marks, inches. Times base 1, call that the bottom, plus base 2, call that the top. 12 was the height, over 2. You see, we're not using these 15s to calculate the area. And I'm just going to concentrate on the area. Okay, so using my calculator, let's do the parentheses first. Clear this out. I'm going to do the parentheses, 26 plus 8. Hit my equal sign there, times 12 times the height. And finally, I'm going to divide that by 2. And I get 204. Sorry about that, gotta knock that over. 204 inches square. I want to label the drawing. Okay, let's look at this next one. Okay, we can look at it two different ways. But I think you have to look at this. This is kind of looks, it's a kind of a different type of trapezoid, but it has the same formula. This is the base 1. This is base 2. And this distance right here is your height. We're not going to use the 13 to figure out the area. So area equals the height, 11, times base 1 plus base 2 divided by 2. So let me slide that over. Area equals the height times base 1 plus base 2 divided by 2. So I'm going to put this in my calculator. 11. I can just do it this way too. Put in the parentheses 14 plus 7 parentheses divided by 2. I could enter it directly into the calculator if I have this calculator. Other calculators might be a little different, but on this one, I can just put it in directly and it equals. I get 115.5 feet squared. Okay, if I don't have this calculator, remember I'm going to add the 14 plus the 7. Hit equal times 11. Hit equal divided by 2. Hit equal. Same thing. Okay, let's look at this next one, C. We'll probably just do these three, and then I'll let you try some. This is the one a lot of students have trouble with. These are all in centimeters. Okay. It doesn't look like a parallelogram because this isn't parallel to this. They aren't parallel. So what you have to do is kind of think of this as being rotated. You see, this is your base 1. This is your base 2. And this distance straight up and down is your height. And this 25 we're not going to use. So now it's rotated back. Area equals height times base 1 plus base 2 divided by 2. Area is the height, 20. See, it looks like the top, but it's not. Base 1 is 19. Base 2 is 4. And then we're going to divide this whole thing by 2. You can also save a little time by dividing the 2 into 20 right away and saying, okay, to save a little bit of work, that's just going to be 10 times 9 plus 4 is 23. You can do this multiplication first, division first, I should say, and then the parentheses, and then multiply it. 230 in centimeters squared. And that is correct. All right, so that's pretty much the idea. Is there any more here? No. So you kind of want to work on these. One thing I do want to show you. Suppose we had this figure right here. A lot of people have some trouble with this. We have this figure here, 27.2, and this is 25.2, and this is 18.7, and this is 8.1. But they have, let's say we want to find the missing dimensions. How do we do that? Well, you see this side and this side, these two measures have to add up to the bottom. See how that is? So how can I find this missing dimension here? Well, I'm going to take 25.2, take away 8.1, get 17.1. 17.1 plus 8.1 is going to give me that measurement. And what about here? Say I want to find those two dimensions. I have a different color. This side and this side are going to add up to this side right here. We're going to do the same thing. 27, right here, 27.2 minus 18.7. And again, you could use a calculator. 5, 8 from 16 is 8. 8.5 will give you this measurement right here. See? So you just take the one you know from the total distance, and this number and this number have to add up to 27.2. Okay. Now, if you want to find a perimeter, you're going to add all those numbers together. You just pop them into your calculator if you wanted to. 8.1 plus 8.5 plus 17.1 plus 18.7 plus 25.2 plus 27.2 equals. 104.8. I can double check it by, let's just go up here, 8.1, 8.5, 17.1, 18.7, 25.2, and 27.2. I want to go around in one direction. I don't want to go here, 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 and get myself confused. And because this is in, I forget the units on this one, these were meters, then this is just going to be meters. Now, what if I want to find the area of this figure? I want to find the area. To find the area, I'm going to split it up into two parts, 1 and 2. I'm going to find the area of this part, area of 1, which is going to be 18.7 times 25.2. Then I'm going to find the area of number 2. And now I know this is going to be 8.1 times 8.5. I'm not going to use the 17.1. It's this distance here, 8.1 times 8.5. And again, I'm not using this measurement here. I'm using the area, length times width, and the area. Then when I get through, I'm going to add these together. So let's try this. See what we get. 18.7 times 25.2, 471.24. And then the little smaller one, 8.1 times 8.5, 668.85. Be careful about your decimal point. Plus, I'm going to move it over here just for a second, 471.25.24 equals 540.09 meters. This is your perimeter. Okay, so that's the whole idea behind it. And it's not the perimeter, it's the area. What am I saying here? I thought something was kind of weird there. Sorry. So this would be meters squared. Let's get it right here. Lost concentration there for a second. Okay, so this is the area. We're going to add those together. You see? So you're going to find area 1, area 2. And you got to kind of use a little mathematics here to kind of figure out the missing sides, just little basic ideas. All right, hope this helps. And then we're going to discuss 8.3.